Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Thank you for the opportunity to speak at this meeting today. It is truly an honor to be here as the Director of National Geophysical Research Agency. Today, I want to share with you some key insights into how geophysics plays a critical role in building a safer, more resilient, and sustainable future for our nation. Let's begin with the basics. Indonesia is located on the Pacific Ring of Fire, one of the most geologically active regions in the world. We face multiple natural hazards, from earthquakes and tsunamis to volcanic eruption and landslides. This is where geophysics becomes essential. Geophysics allows us to understand what's happening beneath the Earth's surface, things we cannot see with the naked eye. Without geophysics, we would be blind to the risks that surround us every day. Geophysical data help us not only detect hazards, but also quantify them, understanding their potential magnitude, frequency, and likely impact. In other words, geophysics translates raw natural energy into readable information that decision makers can use. Now, let's look at how geophysics benefits multiple sectors for our society. First, disaster mitigation. We rely on seismic and GNSS networks for early warning system. We use magnitude theorics and geoelectric monitoring to keep track of volcanic activity. We develop earthquake hazards models that guide building codes and emergency response. Second, energy and mineral exploration. We apply gravity, resistivity, and seismic reflection methods to locate geothermal energy and mineral resources. Indonesia has enormous geothermal potential, and geophysics play a central role in mapping and monitoring this resource sustainably. Third, infrastructure development. We conduct subsurface surveys to ensure safe construction of tunnels, bridges, and city infrastructure. Underground faults, cavities, or weak zones, these must all be identified beforehand. Geophysics helps prevent structural failures and long-term maintenance issues. Fourth, environmental monitoring. We use magnetics and gravity measurements to analyze changes related to climate and land deformation. Geophysics supports the monitoring of groundwater depletion, sediment movement, and even glacier retreat in polar studies. Fifth, marine and coastal application. Geophysical surveys along our coast help us monitor erosion, detect submerged faults, and assess tsunami threats. This is vital in a country with over 17,000 islands and long shorelines. Sixth, agriculture and water resources. Electromagnetic and resistivity techniques help map soil moisture, aquifers, and salinity zones. This guides sustainable water usage and help farmers adapt to climate challenges. Of course, this journey is not without challenge. Many of our data systems are still fragmented and not well integrated. Each region may use different platforms, formats, or standards, making national level analysis difficult. Some regions, especially remote islands, lack adequate equipment and trained personnel. This leads to gaps in coverage and uneven risk preparedness, and often there is limited collaboration between universities, government bodies, and private sectors. Too many research projects remain isolated, underfunded, or unpublished. We also need to adopt more advanced tools like artificial intelligence to process complex data efficiently. AI can detect microseismic swarms or volcanic tremors in real time, which would be impossible to monitor manually. We must also address policy gaps. Scientific insight must be translated into clear regulation, construction codes, land use plans, and public awareness strategies. Only then can science lead to action. So what can we do to move forward? We've outlined a strategic roadmap. First, we are developing a national microseismic zonation map. This will serve as standard for safe urban planning and development. Every city, every province will have a seismic risk index easily accessible to planners, developers, and communities. Second, we are introducing AI and machine learning tools for seismology. These systems will detect microseismic activity and anomalies in real time. They can help us to anticipate the behavior of active faults and volcanoes with greater accuracy. Third, we are investing in the deep sea geophysics. We aim to map the seabed of eastern Indonesia for energy security and national defense planning. Submarine faults and volcanic ridge could pose tsunami risk, and we must be prepared. Fourth, we are strengthening international partnership. We are proud to participate in global initiatives like GEP, IRIS, FIDEP, and others. Through knowledge exchange and joint monitoring programs, we elevate our capacity to respond to regional and global geohazards. Fifth, we are promoting open science. We believe in open data, open source tools, and open collaboration. This allows young research to contribute and accelerate scientific innovation. Sixth, we are encouraging geophysical startups and entrepreneurs. The private sector has a big role to play, from AI platforms to mobile geosensors. We support innovation that solves problems on the ground. But at the core of all progress is people, our human capital. We must modernize our geophysics education system that includes up-to-date curricula linked to real data, hands-on lab and field training, opportunities for international collaboration, and most importantly, fostering a mindset that values critical thinking and real-world impact. We also need to improve access. We must ensure that students from the Eastern Indonesia, from rural and indigenous communities also have opportunities to study and contribute to this field. Because resilience must be built everywhere, not just in cities, but in all parts of archipelago. We need more scholarship, mentorship, and feels cool, especially in hazard-prone regions. And we need role models, geophysics who inspire, who lead with both science and art. Let me end with this. Geophysics is not just about studying rocks or seismic waves. It's about translating risk into readiness. It's about turning underground potential into national policy. It's about saving lives and enabling development that is smart, safe, and sustainable. If we work together across disciplines and institutions, we can make geophysics a key pillar of national resilience. Thank you for your time and attention. Stay curious, stay collaborative, and continue creating impact through science. Wassalamualaikum warahmatullahi wabarakatuh.